Hello my dear students, I'm Dr. Vaishaly Bharambe. I've been teaching anatomy for the last 25 years and I love it. I want you to sit comfortably today. I'm going to talk about something very interesting and very important. So get ready and let's begin my discussion on chromosomal abnormalities. Now this is my series of chromosomal abnormalities. This is part 2 of that series. Okay. Question is, when do I say a chromosome is abnormal? I say a chromosome is abnormal when either the number is changed, the structure is changed, or the arrangement of chromosomes is changed. So, chromosomal abnormalities therefore can be structural and numerical. Structure is when a bit is broken off, bit of chromosome is broken off, bit of chromosome is added, and so on. Numerical is when there is increase in the number of chromosomes or decrease in the number of chromosomes. As you know, all of you know about Down syndrome, so you know there is an increase in the number and therefore that is a numerical chromosomal abnormality. Right, but today, in my last lecture, I have covered the following 5 chromosomal abnormalities and today I am going to talk about translocation and isochromosome formation, just 2 chromosomal abnormalities. Okay, so let's begin by discussion translocation and isochromosome. Both of them come as short notes for you. So you must be prepared, and you do see a lot of translocations in day-to-day life. Fine. Some basics before that. Remember students, you can see a translocation in any cell. Or you can see an isochromosome also in any cell. It can be somatic, it can be gonadic. If it is somatic, the person himself or herself will show symptoms. If it is in a gonadal cell, it will be passed on to their progeny. Okay, this is a basic all of you must understand and remember and put in your answers. One more question. Madam, why do chromosomes really create abnormalities? Acha to chal raha tha. Why do you want to create abnormalities? Abnormalities happen because chromosomes have a habit of breaking. They break. They become, the broken ends are sticky. They stick around and they create new chromosomes. That is how chromosomal abnormalities occur. Sometimes after breaking they get lost. So a bit of chromosome is lost for good. Right? Finally, there is something called balanced and unbalanced. Remember, all these are concepts you have to have if you want to study chromosomal anomalies. If after a break, there is neither loss or gain of a chromosomal material, it is called balanced chromosome abnormality. But if after a break, the bit of chromosome is lost or gained, then it is called as an unbalanced chromosomal abnormality. This is a term we will be using repeatedly, so you need to understand this. Fine, let's begin translocation. What does it mean? Translocation, shifting from one location to the other. That is what is translocation. It's one of the most commonly seen abnormality in human body, structural abnormality. And it is almost 1 in 500 cases of human beings have a translocation. You are not able to imagine it? I'll show you how to imagine it. Take a look at these 2 chromosomes. Okay? Each of them develops a break in it. The new chromosomes are broken. What happens? The broken off bits go and get attached somewhere else, as you can see. This is translocation. When a chromosome breaks at one spot, goes somewhere and gets attached to some other chromosome, it's called translocation, shifting of location. Correct. Right. So there are types of translocations. One of them is called as a reciprocal translocation. What does it mean? Between 2 chromosomes, there is reciprocal transfer of chromosomal material. It can be that both the pairs exchange material, which is really not the case at all. Or it can be one of each pair exchanges material, which is what is seen routinely in human beings and is called as heterozygous reciprocal translocation. Chromosomal number, is it affected? No. Let's take an example here, 11-22 translocation. This is 11, that is 22. Each of them develop a break in it. The broken bits get lost and the new chromosomes are formed as follows. The lost bits go and get attached to the opposite chromosome. There is mutual exchange of chromosomal material. and therefore it is called reciprocal translocation. Between you and me, there is the translocation of genetic material. Is there anything lost or gained? No. Therefore, what should I call it? Balanced translocation. Translocation 1122 is a balanced translocation. Fine. So does it lead to an abnormal phenotype? Not really. Nothing is lost, isn't it? But these people are characterized by low fertility. Why, madam? Why like that? You should be asking me this question. Why is it like that? It is like that because, now look at these two chromosomes, okay? One of each is normal, one of each is translocation. How will they pair? See, this 11 will pair with its partner, but this bit, the distal bit of my 11, will have nobody to pair with. Its bit is translocated on 22. How will they pair? So see what the chromosomes do. Chromosomes pair in this manner, which is called as the Pachytene quadrivalent. Can you say it once? Pachytene quadrivalent. Packed together to form something like a quadrangle. Okay. Now I want you to imagine how gametes will be formed. One of each pair will go to the gamete, right? So maybe the chromosome 11 here and the chromosome 22 here go to the gamete. In which case gamete is completely normal. But the other gamete therefore has the translocated chromosomes received, and therefore it is abnormal but balanced. Okay. So this is scenario number 1. There is another scenario where these two 11s go together. The 11 goes to the gamete along with a bit of 22. The 22 goes to the gamete along with a bit of 11. Okay. Now I want you to imagine that the gamete is receiving so much of 11 in this case and so little of 22, or so much of 22 and so little of 11. Another scenario is where the 11 goes with the translocated 22 and the 22 goes with the translocated 11. Basically, all gametes are abnormal and imbalanced. Okay, and what happens is they result in partial monosomy or partial trisomy. I am telling you, and it is possible that you might have understood, but often I as a student never really understood this. I'll take you to an image now. This is the abnormal gamete. Can you see a normal 11 and a 22-11 translocation here? This is fused with it meets with a normal gamete. The progeny that is formed will have one normal 11, one more normal 11, one normal 22, okay, but one translocated 22, which is having less of 22 and more of 11. So this child that is formed will have partial trisomy 11, partial monosomy 22. Are you understanding this? This child will have extra 11 and less 22. Partial trisomy, partial monosome. Okay, so let's summarize this as follows. One normal gamete, one abnormal unbalanced gamete, and 4 unbalanced and abnormal gametes. So 2/3 of the gametes will lead to abnormal progeny. If the progeny is normal, great. If the progeny is abnormal, having partial monosomy or partial trisomy, then it will depend on whether that such trisomies have viability. Most of the trisomies, as you know, are non-viable. So it will result in repeat abortions. That person will keep coming to the doctor saying, I've lost another child, I've lost one more child. So unless they realize that they are having a translocation, which is gonadal, and that is the reason why they are losing so many babies, this person is just termed as infertile. Okay, and this is how infertility is associated with translocations. Right. Students, if you're enjoying this lecture, do please like and subscribe to my channel. Do visit the website for solving MCQs. For every lecture I upload, I put up MCQs on the website for you to practice MCQs. Remember, another few years and you will be going in for entrance exams. You have to keep on solving MCQs. Okay? Alright. Let's continue with our lecture now. I want to introduce to you now the concept of Philadelphia chromosome. Take a deep breath Maybe have some coffee, water, something, and let's begin Philadelphia chromosome. What is Philadelphia chromosome? Nowell and Hungerford in 1960 discovered what is called as translocation of chromosome 22 on chromosome 9. That means bit of the long arm of chromosome 22 got broken off and got attached to long arm 9. This short chromosome 22 is called as Philadelphia chromosome. Okay, 9q is found to be very long. This picture is seen in 85% of cases of chronic myeloid leukemia. And this is the first case where there was a clear connection found between a genetic abnormality and a cancer. This was revolutionary thinking because we never really thought that chromosomal abnormalities could lead to cancer. But here was living proof of it. This is a short note, students. Do listen to this carefully. Some more odd findings were found. This abnormality was found only in the granulocytes, thrombocytes, erythrocytes of that person. His rest of the body was completely normal. So what we understood was this person was a mosaic. His rest of his body was normal. Only these cells were showing Philadelphia chromosome formation. This seems to be some kind of an mutation or translocation that they have acquired during life. It isn't that they were born with it. What is even more important, it isn't something they will pass to their progeny. Thank God for that. It's not happening in gonadal cell, it's happening in their other cells. Therefore, he will suffer from chronic myeloid leukemia, but he will not be able to pass it to his offsprings. That's Philadelphia chromosome. Ma'am, are we done with translocations? No, students, I'm not done with translocations. There is one more translocation you need to understand. It's important from point of view of study of Down syndrome. So the last type of translocation we should study is called as Robertsonian Translocation. What happens in it? Understand that there are two acrocentric chromosomes. Okay, here in this case I've shown you chromosome 14 and 21. Each of them develops a break in it, very close to the centromere. The broken off P arms unite to form a tiny fragment. This tiny fragment is lost. Why is it lost? It's lost because the fragment is so small and it is so slow in replication that most of the time it is unable to reach the spindle and it's usually lost during cell multiplication. What about the Q arms which were left behind? The two Q arms unite to form a long chromosome, which is a 14-21 translocation. Okay, so now what happens? A cell is containing one 14 chromosome, one 21 chromosome, and one 14-21 translocation. Has the number of chromosomes reduced, students? Yes, we've lost one chromosome, right? This is called as Robertsonian Translocation. This was first observed by scientist Robertson in a phenomena in grasshoppers. It is a translocation between acrocentric chromosomes. The two new chromosomes have an interchange of the two arms fusing together so Q arms fuse together and the P arms fuse together. The fused P arms are lost. And what is left are the two fused Q arms. Okay, so this is your 14-21 translocation, also called centric fusion. For common sense, it's very close to the center that they fuse, so it's called centric fusion. The number of chromosomes is reduced, but I still want to call it balanced. Am I right or wrong in calling it balanced? What do you think? Actually, I'm quite right in calling it balanced because the material that is lost is so tiny and it is almost completely heterochromatic, and therefore the person can actually live quite comfortably without it. So it is considered as a balanced translocation or balanced chromosomal abnormality, very commonly found between chromosome 13 and 14. What happens during gametogenesis? Let's take a look. This is amazingly interesting. I hope you find it as interesting as I do. Right. So here you're seeing a person with a 14-21 translocation. He or she is producing gametes, 3 chromosomes to be passed on into 2 gametes. Okay. So either the 14 and 21 go to one gamete and the 14-21 translocation goes to another gamete. So a completely normal gamete is produced, giving rise to a normal child. Or a 14-21 translocation gene, which is translocation, which is a carrier, but doesn't really, it's a carrier. There are other two scenarios that you should consider. One is that the 14-21 translocation travels with the 21 chromosome. Now this is very important. In this one gamete, there is one normal 21 and there is one extra 21 Q arm. That means if this gamete was to fuse with a normal gamete, the person would have 3 of chromosome 21, which would lead to Down syndrome. Absolutely. The other gamete would have one chromosome 14, no 21 at all. A third scenario where 21 goes on his own and a 14-21 translocation goes to the gamete along with 14. Now understand that this one leads to a Down syndrome, whereas all others lead to death. These are lethal. You cannot do without autosome. So if 14 goes on his own with no 21, there is no viability at all. The most of the embryos cannot do without autosomes. So autosomal deletion will lead to abortion. Right. So let's talk about Robertsonian translocation gamete formation. 1/6 chance of a normal baby, 1/3 chance of abnormal baby or carrier formation, and 1/2 of the gametes will result to a lethal outcome. Definitely the parent will have infertility issues. What are the translocation examples? They are examples where there is translocation between 13, 14, 15, 21, 22, the acrocentric chromosomes. Right. 3% of the Down syndrome babies have this Robertsonian translocation. For example, there can be translocation 21-22, translocation 14-21 like we just saw, or 21-21 on itself there can be a translocation, and 13-21 translocation. Right, so should we revise the translocation quickly? It's a very common short note, students. We have to define translocation, you should draw to explain it. Talk about the types of translocation, reciprocal translocation, Robertsonian translocation. What are the features of reciprocal translocation? Discuss abnormal gamete formation. Remember, Pachytene quadrivalent. Explain why it is associated with low fertility and discuss Philadelphia chromosome. Now remember, take my advice, students, unless you draw it on paper, the features don't come out of your brain. This is a lot of random information. ऐसे ही थोड़ी ना आंसर आने वाला है. You need to put it on paper, quickly draw it, and you will find yourself answering very fast. Practice the diagrams as I've shown you, and you will find yourself answering better. Right. So we have now discussed translocation. We need to now discuss isochromosome formation. This is a short portion, students. We are almost there. Isochromosome, another commonly asked short note. This is interesting. Normally, we know that a chromosome goes through a vertical splitting to form two chromatids in cell division. Suppose instead of this, it goes through a perpendicular misdivision, okay, like this. Then what will happen? The chromosomes formed will be one chromosome with 2q, one chromosome with 2p, which are identical. This is a metacentric chromosome. Two metacentric chromosomes developed by cell division. Another way this can happen is you can have two divisions as shown. One cut in the P arm, one cut in the Q arm. The Q arm now goes and fuses at the point where there is a P arm and vice versa. Right? So this is called as whole arm centric fusion. What is it called? Whole arm centric fusion. And again the result is the same. There is one metacentric chromosome with 2q, one metacentric chromosome with 2p. Right. So this is what is isochromosome formation. Question is, so what? Now ma'am, we've seen too many abnormalities. How does it matter? Of course it matters. Here you are seeing a X chromosome which is isochromosome having two Q arms. Okay. So it's called as 46X isochromosome XQ. What happens here is that The short arm is generally carrying the genes for normal sexual characteristics. That arm is missing. Q arms are there, but the P arm is missing. So what happens? The person has features phenotypically Turner syndrome. Okay. So if you're looking at the case and you're thinking, yeah, this is Turner's, and then you go do their chromosomal study and you find that, oh, this person has 46 chromosomes, not 45. She's not Turner's. You are neither correct nor wrong, because the patient is very much Turner syndrome because she doesn't have the P arm at all. But she doesn't have an entire loss of chromosome, which is normally what we see in Turner syndrome. This is a Turner variant. Okay. So this case will show a large chromatin body. So you can do a basic bar body test to understand. You find a large chromatin body, you think, okay, there is something abnormal with the X. Let me check this case better. Another thing that can happen is there can be two P arms. So just like there's isochromosome Q, there can be an isochromosome P. This patient will develop as a normal looking female, but she'll have streak ovaries. So no external manifestations at all, but when you look at the ovary, there are streak ovaries. Okay, so that is isochromosome X. Now question is, ma'am, what about isochromosome of autosomes? What will happen if I have got two autosomes uniting to form isochromosome? The offsprings will be trisomic or monosomic, isn't it? So if I've got 2Q of 21, then the result will be obviously trisomy 21. But again, the result will depend upon the viability of that creep. So if you are resulting in trisomy of say 11, it's not viable. So the result will be repeat abortions. It's only isochromosome 13, isochromosome 18, isochromosome 21, which will result in a normal viable baby. Not normal, but a viable baby. So only chromosome 13, 18, 21 will result in viable trisomies. Right. So with this, we complete isochromosome formation and translocations. I want you to now think of another common section to this answer. Even if the note is on translocation, even if it's on isochromosome, this is a common section you will be putting in your answer, which is, what are the causes that trigger chromosomal abnormalities? What causes a cell to go into translocation or isochromosome formation? One is completely random, spontaneous. Other causes can be ionizing radiations, as we saw what happened in Hiroshima, Nagasaki. Or it can be some viruses which trigger such abnormalities. Or it can be some chemical carcinogens, which is why we say that, don't pack up the environment with so many carcinogens, because they're going to stimulate such chromosomal abnormalities. Mutants, your very interesting word, which has resulted in so many fun movies for all of you. Mutant, you are triggering mutations. Late maternal or paternal age does result in chromosomal abnormalities, and some genes themselves cause chromosomal abnormalities. So, students, let's quickly revise what we learned today. We learned about translocations. We know that it's a very common short note. Philadelphia chromosome itself is a 2 marker. We then learned about isochromosome formation. We talked about how isochromosomes are formed. Either it is a division which is perpendicular to the normal or whole arm centric fusion. I've told you must draw to explain it. Effects of isochromosome X, effects of isochromosome autosomes. And finally, the common short note is isochromosome formation. Students, for all MCQs on all chromosomal anomalies, do visit my website. For every video I upload, I always put up MCQs for all of you to practice. Why should you practice MCQs? Of course, you have to practice because at the end of another few years, you will be giving entrance exams for your post-graduation. You need to have your MCQ in practice, otherwise you will land up making errors there in the entrance exam. If you enjoyed this lecture, do please like and subscribe to my channel. It will encourage me to create more of such knowledgeable videos for you. If you can put in the comment section what it is you like and what it is you do not like, I can alter them so that they serve your purpose better. The aim, my dear students, is always to achieve standard in your education. This is not done just because I find some crazy pleasure in teaching you. It is being done because all of us need to achieve a standard in medical education. This is the minimum that you should know on topic of translocation and isochromosome formation. Okay, so I enjoyed taking this class, students. I hope you did too. Please make use of this video to answer your short notes on translocation and isochromosome formation. See you across the screen in some other video.